Hi, good morning or afternoon, wherever you may be. Welcome to session 2 of day 4 of Azure Data Week on infrastructure as a code in Azure with Sean. So I'm going to stop jabbering and let Sean get started. Sean, go ahead.
Good morning. Good morning, everyone. Thank you for having me here at this great event. I've been a friend of Pragmatic Works for a long time, even before I joined Microsoft. So it's cool to be invited to speak at this event. So my name is Sean Weisfeld. I am a cloud solution architect at Microsoft on the One Commercial Partner team. My team focuses on working with partners, Microsoft partners. Those could be folks like Pragmatic Works. It could be consulting partners. It could be reseller partners. They're all different kinds of Microsoft partners. So we work with those teams. My team covers all 3 of Microsoft's clouds, from Azure to Dynamics to Office 365. My focus area is on the Azure side. Specifically, I focus in the Azure DevOps toolchain, whether that is our tools with the Azure DevOps stuff or some of the open source DevOps tools as well I'm familiar with. So I've been with Microsoft for many years, for about 6 years now. My email address is on there. I'm based in Austin, Texas. So it is 8 a.m. for me. So the sun is just peeking into my office window here. My email address is on here. Feel free to hit me up if you have any questions. I do my best to get to answer email promptly. But as you know, like just about everybody at Microsoft, I get about 300 emails a day. So so bear with me there. Moreover, this deck and all of the code samples and demos and whatnot that we're going to see today have been posted out on GitHub. There's a bit.ly link right there, and I'm going to copy and paste it into the chat so that you don't have to try to type it. And because bit.ly is case sensitive, and that's a little bit annoying. So there's a bit.ly link. You can go out to the GitHub repo, grab the deck, grab any of the PowerShell scripts or ARM templates that we're going to play with today, and have that stuff for your edification later on, and it'll live out on GitHub forever. It'll also be posted with the rest of the conference presentations and whatnot. So with that, let's get through. So I got a shameless self-plug. Outside of my day job at Microsoft, I run a website called User Group TV. All the content up there is free. We have over 975 hours of stuff up there. Basically, when I see community events, I try to record them and post that stuff online. It is definitely not almost 1,000 hours of me talking. It is 1,000 hours of people from the community. So pretty much anywhere I can drive to and record, I try to record and post that stuff. Lots of great content from lots of great speakers. So let's get started about talking about infrastructure as code. And when we talk about infrastructure, I got this great picture of a bridge. But when we go to build a bridge, there's many different ways we can build a bridge. When we go to deploy our infrastructure, the bits and pieces that make up our application, there's many different ways to do that. And I'm going to focus today on this infrastructure as code topic. So at the end of the day, what is infrastructure as code, right? Right. It's this idea that I'm going to be able to deploy these resources using this descriptive model and using a lot of the same versioning and source control and techniques that our developers have been using for their source control, C#, Java, .NET, whatever, for their code for many, many years. The cloud has been a real enabler to this technology. Historically, when I've needed a virtual machine, a database server, what have you, historically when I've needed to build that type of a thing, I've needed to call up IT, go buy a server, and do all of this stuff that I couldn't automate that process, right? I had to get approvals. They had to go through procurement, right? Nowadays with the cloud and with modern cloud technologies, right, I can just ask the cloud and say, hey, give me a server, give me an instance of a database, right? Give me these resources and they'll be provisioned for me. Moreover, I can configure all of those resources using those same techniques. That gets me a lot of advantages because Now, if a developer or needs an environment to do testing for an hour, I can go provision that environment, let that developer use that environment for an hour, and then have that environment go away when they're done, right? When I need to make an upgrade to an environment, I can upgrade that environment and keep that upgrade information stored in a source control system so that it can be versioned and managed and go through the same approval processes and sign-off processes and release processes as actual code would go through. Right, what that gives me is all those same benefits, right? That audit trail. No longer do I have to question why did this setting change in this production environment, right? I know why everything changed because any changes that happen in my production environment, I can lock that production environment down so that any of those changes that happen are recorded in source control and have gone through the same type of approvals that I would go through if I'm actually deploying a piece of code. Right, what that allows me to do is allows me to step away from manually configuring my environments, RDPing into a VM and pressing buttons and changing registry settings, and then confusing folks. Right, gigantic Word documents that say to deploy, do this, do that, do the other thing. Right, get away from all that stuff and store all of that information inside of source control, where I can diff it, I can version it, I can have all the controls that I have for code deployments and for code compilation, pull requests, all that stuff that Stan have talked about in the last presentation. Right, so this infrastructure as code idea has these big major goals. Right, first we want to eliminate drift. We want to eliminate people going in, changing random things in the production environment, not going through the right change control process, and then having that cause us a problem going on. Right, we also want to eliminate inconsistencies between environments. Right, I want to have my production environment, my dev environment, my test, QA, whatever environments I need, I want to have them all configured the same way. Right, and when I'm testing a configuration change, I want to test that configuration change through the entire life cycle of environments to make sure that configuration change is appropriate before it hits production. Right, no more, I live in Texas, no more cowboys. Right, so I can eliminate those inconsistencies between the between the environments. Right, I also want to make now, so let me take a step back. When I say the configuration changes, I should also point out that that does not necessarily mean that the configuration of all those environments is exactly the same. A good example of this is in my production environment, I might want a 4-core box with 64 gigs of memory for my database server. I want a big honking machine to go handle that, or I might want to scale that out to multiple nodes. Right, I might not need that scale in my dev test environment, so I don't have to have them configured exactly the same, but I can parameterize certain pieces of my configuration so that I can have some of those differences where they make sense. Right, obviously, I probably don't want to pay for a 10-node cluster in my dev environment for the one developer we have on our team. Right. I also want my deployments to be repeatable, automatable, and fully documented, right? I want to be able to say, to be able to have my deployments happen all the time without human intervention as much as possible, as much as makes sense. One of the guys on our Azure DevOps team has a great series of blog posts, and in one of his blog posts, he says, if it hurts, do it more often, which goes counter to everything my mom told me when I put my hand on the stove as a kid, right? Put my hand on the stove, it burnt. She said, why'd you do that? Don't do that again. It hurt. Don't do it again. But DevOps says, if it hurts, I want to do it again. I want to do it as many times, because the more times I practice doing that, right, the better I'm going to get at doing it, and it's going to hurt less over time. Right, I'm going to put in place better processes, better techniques, better tools in order to make it hurt less and have that process work better over time. Right, so that some other piece of my DevOps pipeline then hurts the most, and I can go off and tackle that. But I want with my deployments for them to be repeatable, automatable, and fully documented, right? The documentation features the ability to version things and change control things and comment on things and pull request things, all of that great stuff that I get with being able to take my infrastructure, the configuration of my infrastructure, the deployment of my infrastructure, and stuff that in code and store that code in a source control system. So there are many popular options for doing infrastructure as code in Azure. There's some great stuff being done by third parties, which provide vendor agnostic overviews. Staniff talked a little bit about it in the last session. Vendor agnostic ways of deploying things. So I can write, for example, a script in Terraform that says deploy a virtual machine, and then use that Terraform's technology in order to use that same script with very little modification to deploy a virtual machine to different cloud vendors or on-prem or things of that nature. So there's a number of these third-party products out there. I mentioned Terraform. There's also Chef and Puppet, and also Ansible from our friends over at Red Hat. So there's a number of these third parties. Today, I'm going to be focusing on the features that are built into Azure. At the end of the day, all of those third parties, when they are deploying things to Azure, have to end up calling ARM and have to end up using the Azure tooling. They're just obfuscating that with a layer of indirection. Right? How do they say you solve any problem in computer science by adding a layer of abstraction? So there are pros and cons there, right? The flexibility of being able to write one Terraform script to deploy to multiple clouds is kind of nice. But that being said, when we deploy a new feature to Azure, or if there's some nuance difference between the way Azure does something and another cloud, the Terraform or any of the third-party tools might not yet have that feature. They might or that community might choose to not implement that feature. So the ARM tools, the Azure CLI, are always going to be the highest level of fidelity, for lack of a better word, to the Azure platform. But they are specific to the Azure platform. Now, that being said, obviously you can run Azure in the public cloud, which is what most people think of. I have an Amex card, I go out and buy cloud. We also offer community clouds like the cloud that we have for the US government or the cloud that we have out in China, or even on-premise clouds with things like Azure Stack, where I can write the same ARM template, run a deployment script to deploy resources to Azure in the commercial cloud or to Azure in one of those private or community clouds. Which really gives you that, if you go down the Azure bandwagon, it really gives you that nice hybrid story of being able to do everything the same. For example, one of the partners that my team works with, they actually deployed Azure Stack on a cruise ship, because obviously the cruise ship doesn't have the highest levels of connectivity when they're out at sea. So things like that. So again, we're going to focus on the top two guys, the ARM templates and the Azure CLI and Push scripts. So we can't talk about ARMs without a picture of the rock, because I mean, look at those arms. I can only be jealous. So what is ARM? So at the end of the day, Azure has this fabric, this underlying core piece of infrastructure that operates it itself, right? That core piece of infrastructure is implemented using ARM. It is the Azure Resource Manager. It is the underlying control plane that operates all of Azure. So every Azure service uses ARM to deploy itself, to talk about itself. So when one of our product groups, whether they're the SQL team, the infrastructure team with virtual machines, regardless, whatever service they're building, when it comes time to take that service and they need to hoist it into Azure, they write some glue code, some instructions that teach the Azure control plane how to talk to that service. right? That glue code is called a resource provider. You can actually write your own. Some of my partners actually do that. They write their own resource providers for their own services that they're going to deploy into, for example, the Azure Marketplace. It's a little bit of an edge case. Not every, I'd say a small percentage of customers are going to be doing that, right? Creating their own Azure services. So I have this control plane, Azure Resource Manager. It sits underneath all those services. Now, anytime you interact with Azure as a customer, as a user of the system, you're talking to that control plane, right? So when you want Azure to say, hey, if you want to tell Azure, hey, Azure, create me a new VM, create me a new SQL database, you're going to reach out and tell ARM to go do that. When the control plane, the first thing that we deploy when we release a new service is a RESTful API in order to talk to Resource Manager and that resource provider in order to perform that action. So that's like the first thing. So you can actually, with any REST client, I was working with a partner earlier this week. We use Postman to call Azure to have it deploy something. So with that RESTful client, I can do everything I want in Azure with that RESTful client. However, using Postman, using a RESTful client is not the most easy way to deploy resources. So what you'll see is a lot of demos and a lot of folks using the Azure portal, right? That's a regular HTTP-based portal that allows you to go in and deploy resources. The thing that I really love about that portal, it is that things in the portal are super discoverable. I can go to the portal, I can see a list of things, I can click on those things, I can drill into them, I can find more information about them, I can see all of that stuff, right? I can see what properties are available. Everything in the portal is super discoverable. So it makes it really easy to use. The drawback of the portal, it is not super automatable, right? When I have to do things repeated, writing steps in a Word document that say go here, click that, right click here, whatever, doing that is not really automatable. It's not repeatable and doesn't get us where we want to go on our DevOps type of a journey. So on top of that, we offer a number of SDKs that allow us to talk to Azure. For example, we have a .NET SDK that allows you to write .NET code that talks to Azure. However, most commonly, when folks are writing automation code for Azure, they're using either the Powershell plugin or the CLI plugin. I'm a huge fan of the CLI plugin. The PowerShell plugin's great. It's really a matter of, in my opinion, preference. Which one sings to you? Which one feels good to you? We'll take a look at the CLI one during our talk today. Moreover, using the CLI and PowerShell, I can deploy. I can not only execute procedural step-by-step instructions against the platform, deploy this, create that, configure this. I can also deploy declarative templates that allow us to say, I want an environment that looks like this. And we'll take a look at one of those ARM templates here today. So a little bit of vocabulary, kind of get everybody on the same platform. When we're talking about Azure, at the end of the day, what you're doing all this work because you want to deploy resources, right? You want to deploy Azure services that are going to go do things to make your business happen. Whether that's a database, a virtual machine, networking, storage, whatever it is. I mean, there's hundreds of Azure services out there now. You want to deploy those resources, right? Now, when I deploy those resources, I'm going to deploy them inside of what we call resource groups. These are nothing more than a bucket, a container to store a bunch of resources. They give me a way of organizing my resources so that in a large production environment, I don't pull up the list of all resources and have 10,000 things to sift through to see where I'm going. We also have this concept of resource providers, and I mentioned this a little bit a second ago. The resource providers are the way that Azure service lights itself up within ARM, right? So when the SQL team adds a new feature, right, they update their resource provider in order to teach ARM how to expose that feature. And finally, on our vocab list, we have this idea of ARM templates. I mentioned this a second ago as well. These are a JSON document, so JavaScript object notation. So a simple JSON document, well, not so simple, depending on how complex your environment is, but it defines all of the resources that you want to deploy, typically to a resource group. I can deploy ARM templates at different levels in the stack, but typically I'm deploying them at a resource group level. So I mentioned resource groups. We've been talking about it for a second. There are some considerations, some things to think about, some best practices. I hate the word best practices to think about with resource groups, right? Right. When you deploy when you build your resource groups, when you think about what services need to go in a resource group, you want to think about the life cycle of that resource group. Typically, I want all the resources in a resource group to share that same life cycle. I want to deploy, update, delete them. I want to manage those resources together. That doesn't mean that I want to put my whole application, and if it's a complicated application, in the same resource group, right? Maybe, which one? I have many options, right? At the end of the day, each resource can only be tied to one resource group. It can only have one parent. You cannot put the same resource in two resource groups, right? I can take a resource out of a resource group. I can move a resource to a different resource group. When I create my resource group, I'm going to create my resource group in an Azure region. The resources that live in that resource group may or may not exist in that same Azure region. And then a lot of folks usually ask me, well, why do I need to put a region on the resource group? Well, the metadata for that resource group has to live somewhere. And for compliance reasons, we give you the option to pick where that metadata is going to live. Right? A resource group also gives me the ability to control security. So I can control security at a resource group level and say, hey, this resource group contains all my database servers. Maybe I only want the DBAs to be allowed to modify things in this resource group. And any of the resources that are in one resource group can talk to resources in a different resource group. It's not like it is a network boundary or anything like that. So I kind of mentioned this scope. So if we look at this chart, we see that at the bottom we have our resources. Those resources can live in one and only one resource group. So a resource group can have many resources inside of it. Our resource groups are top-level entities inside of our Azure subscriptions. So our Azure subscription can have one or more resource groups. And then we can group subscriptions at this management group level if we want to apply common things across multiple subscriptions. Typically, folks are using the management group level for things like policies, right? They're using things like Azure policies to say that, hey, I need this naming convention, or all of my assets must have this type of tag in place because that's how we're doing chargeback or something of that nature. So another kind of view of that same information here is this kind of a view, right? So I have my resources, in this case, a web application, a virtual machine, and a SQL database, right? Those live inside of a resource group. I can have one or more resource groups inside of a subscription. The subscriptions live inside of the account or the enterprise agreement, depending on how you go about purchasing Azure. So we talked a lot about resource groups, and I mentioned that they have this single hierarchy, right? There's only that each resource can have one and only one parent. So how do I go out and say add additional metadata to my applications, to my resources, in order to be able to group them different ways? And we do that through the use of tagging. So to any resource or resource group, I can apply a tag that says, hey, all of these things are databases, or all of these things are managed by this team, or all of these things are getting charged back to our comms team, or what have you. So I use these to define how things are going on in my how things are laid out in my Azure deployment, so that after I deploy 1,000 Azure services, I'm not getting bogged down in the amount of overhead of trying to find things and things of that nature. And I can write automation based on things like tags in order to group them together. Moreover, I can also control security with the role-based access security system inside of Azure. Today's not a huge talk about security, but I kind of wanted to mention it because I can set those security levels at either the resource level or the resource group level or the subscription level, right? I have those choices when I'm setting security. So I love the title of this slide. I thought this was the best title of any slide in the deck because I thought it was super cute. The importance of idempotence. So it is when we start looking at deploying infrastructure as code templates, like I mentioned, there's two basic ways of doing that, either procedurally through using something like the Azure CLI or PowerShell, or or declaratively via an ARM template. So when I do this, when I do DevOps, I'm looking for this idea of idempotence. What is idempotence? Well, idempotence is the concept that every time I do a deployment, it's going to happen the same exact way, and I can do it over and over and over and over again, regardless of the current state of the production environment. So when I'm looking at something like a procedural system, like a PowerShell script or a CLI script, right? If I want to be able to run that script over and over and over again, I have two options, right? I could either write a whole lot of code in that script that checks the state of something before it actually executes in order to figure out should it or shouldn't execute that piece of code, or I can just destroy the entire target environment and then run the entire creation script again. I know there's a lot of database folks on the call, right? It's the difference between trying to figure out if you need to run an alter script or just drop and recreate it, right? Well, the alter thing gets really complicated really quickly, and in my mind is an anti-pattern. So typically, if folks are telling me they want to do deployments using procedural CLI or PowerShell, my recommendation is going to be, obviously, if it's not a production environment, to destroy the environment and recreate the environment. Now, this has inherent limitations, i.e., it's pretty bad if you destroy your production environment and recreate the whole thing. However, in a lot of dev test scenarios and a lot of DevOps scenarios, this makes a lot of sense because I can always start with a known clean environment. Moreover, I have some partners that I'm working with that'll actually deploy an entire environment for every dev test cycle. So there's no shared environments in their workload. When a developer needs to test something, they deploy a clean environment, test it, destroy the environment. The nice thing about that is they can have as many or as few of them as they want. And they don't have to worry about any cross-contamination with both me and one of my colleagues testing on the same environment at the same time and have some wonky behavior overlapping. Moreover, the most common way we see folks doing automation, high-level, repeatable automation in Azure is via ARM templates. Since these are declarative, I can tell that ARM template, hey, go ahead and destroy the resource group and deploy a new resource group with that ARM template, with all the and then run all the instructions. So I do have that destroy and create option. Moreover, with ARM templates, I can also do an upgrade operation. I can tell the Azure platform and say, hey Azure, I want an environment that looks like this. I want these resources configured this way in this resource group. And Azure can then look at that, say, okay, you want it to look like this. It currently looks like this, right? to get me from A to B, I need to change these things. And then it can figure out that delta and then process those changes for me dynamically. This gives me the ability to upgrade my environments in place without having to destroy and recreate the entire environment. Huge advantage. So we've talked a little bit about this already, right? We can do things via PowerShell or the Azure CLI, step-by-step code. You guys have probably been doing it for a long time. Or we can look at something like an ARM template. I write those ARM templates in JSON and JavaScript object notation, right? It's this declarative syntax where I say, I want it to look like this. Give me one of these versus give me a peanut butter and jelly sandwich versus get the bread, get the peanut butter, get the jelly, take the bread out of the bag, get the knife, take the knife, unscrew the cap of the peanut butter, and so on and so forth. So that takes us into our first demo. And in our first demo, we're going to use the Azure Cloud Shell to create a SQL server because, hey, it's a database conference. We got to create a SQL server. I'm using the Cloud Shell today. I'm a huge fan of the Cloud Shell. Really love the Cloud Shell. Basically, what the Cloud Shell is an instance of the Azure tools, either PowerShell or CLI, running in a little tiny container that you can access via the browser. I have two ways of accessing it. I can either click this little icon here, and that'll open up a Cloud Shell kind of 50-50 inside of my Azure portal. But that would be kind of hard for you all to see since it's kind of squished up on the screen, and I know we're all screen sharing and everything like that. Moreover, if I want to see like a full screen shell, I can just go to shell.azure.com, and that will allow me to log into Azure Active Directory and get myself one of their Cloud Shells. I could do all of this stuff with CLI or PowerShell running locally on my machine and log into Azure and do all this stuff locally. That has some advantages. It's kind of nice to be able to use the Bash or Ubuntu, the Windows subsystem for Linux, to do that stuff directly from the machine. However, especially if you're just getting started out, the nice thing about the shell is you don't have to install anything. You don't have to upgrade everything. You get this nice clean environment to go play with. And if you want to like destroy it, you just delete a storage account, and it'll recreate with a clean environment. So it's very fast and cool. And I say that it's very fast, and it's not loading now. So we'll give it a second, or we'll be impatient and reload it. Shell. Okay. Come on, shell. See, this is what happens when you give a live demo. Come on. There we go. So we can see that my shell, it logged in as me. It's I have it set up to use Bash by default. That's my preferred environment. But you can switch this. You can use this little drop down to switch it over to PowerShell. Right now, what it's doing is it's trying to find me a container to go run this in Azure. Cool thing is I don't got to pay for any of that container. I can just use this Cloud Shell. So here's my Cloud Shell, just like any other shell. I can start asking it some questions. So I can do something like AZ, and I can pull up the good old ASCII art, because no tool is awesome unless it has ASCII art, which gives me a list of what's going on inside of my Cloud Shell, what my Cloud Shell can do. Moreover, if at any time I want to get help on anything inside of the Azure Cloud Shell, I can always do -H at the end. So AZ, in this case, AZ-H, and that's going to pull up the documentation of what I can do at that, where I am or what I've asked for. So for example, let's say I want to log in. I can do AZ login-H, and it'll go ahead and tell me how to go do a login with some examples and all the parameters and whatnot that I might be looking for. In my mind, this makes a CLI as discoverable as a CLI can be. That being said, since I'm using the Cloud Shell, I'm already logged in. It's done that for me by default, so I don't have to re-log in. But I can see a list of all of the different Azure subscriptions that this account has access to. So if I do AZ account list, I can see a list of all of my subscriptions. And I know what you're saying, Sean, that's a gigantic mess. It's a bunch of JSON JSON. I really want to see that as a readable table instead of a big giant list. So I'm going to go ahead and paste the command in. All these commands are in the notes that I gave you the bit.ly for. So here I've taken all that JSON document and I've turned it into a nice little list using the -o-output table command. Now, I like specifying it on every one of my commands because typically I'm writing code that's going to be shareable. But you can also set this as a configuration property in your tool to change the default from outputting to JSON to outputting to a table or a bunch of different other options like TSV or what have you. So that's a list of all the subscriptions. Here I can see that I have access to a whole bunch of them. What I'm really looking for, what I'm usually looking for when I'm hitting this command is which subscription is set to be the default subscription, so that I know that, hey, which subscription, when I execute another command, is that subscription going to go against? In this case, it's going to go against my subscription named my internal subscription or internal consumption subscription. So we can see inside of the subscription a bunch of different information. For example, remember earlier we talked about all of those providers, all of those services that have been made available. I can ask Azure, hey Azure, give me a list of all the providers that are available in my subscription. And we can see that there's a whole lot of them. You can see that a lot of them are from Microsoft, with Microsoft products like Marketplace or Maps or Power BI, right? All of those resource providers are here. We can see which ones are turned on, i.e. they're registered or not registered, and which ones turn on automatically or what have you. We can also see that other partners, third parties, have also deployed resource providers that I can turn on, and if I want to use Raven HQDB, I can turn on their resource provider and then be able to talk to their service right here from the Azure CLI. I can also pull a list of all the resource groups that are available in my subscription. So let's go ahead and do that. So I executed AZ group list. I'll put that to a table. In here we can see all the resource groups. I have a number of them for a bunch of demos that I've been working on for a bunch of different things. I love the obligatory named my RG. It's my resource group because I got to have my resource group. So let's go ahead and create a new resource group. So let's figure out how to do that, right? So if I go to AZ group -H, I can ask it, hey, what can I do? Oh, I got to type correctly, AZ group -H. This is what I get for not copying and pasting it. What can the AZ group command do? Well, I can create, I can delete, I can find out if a resource group exists, I can list a bunch of resources groups, I can show the details for a resource group, I can update a resource group, I can do all kinds of different things on a resource group. So let's say I want to create one. So let's ask the resource group how to create itself. So AZ group create, how does that work? -H. I can pull in and say, okay, well, the create command works like this. I need to provide a location. I need to provide a name. And here is an example of what one could look like. And I know what you're saying. Locations. How do I know what locations are available? Well, let's ask. I happen to think that maybe is an AZ account. So let's see, does AZ account have anything interesting for me? Oh, yes, it does. It has a command called list locations, right? So let's go ahead and list all those locations and output that list to a table. So here is a list of all the Azure regions that my current subscription has access to. I can see their human readable name, their machine readable name, as well as some GPS coordinates so I can find out where they are on the planet if I wanted to draw a picture. So let's go ahead and let's create a database. Right? To do that, I'm going to set up some properties, some variables. I'm inside of Bash here real quick. So I just copied and pasted a bunch of them in. Namely, I want to create a resource group that's named my resource group with a dash. And using this bash command, it'll create a random number. I want to create that resource group in the East US. We just figured out how to find out where those are. I'm going to create a username. I'm going to create a password. Here I'm just generating a random password. And I'm going to create a server name with, again, a random number at the end. I'm using these random numbers to make sure that everything stays unique. And I'm also going to set up some default IP addresses, and I'm going to use this for my firewall. So now let's go ahead and create a resource group. I'm going to go ahead and paste in this command. That will go ahead and create a resource group. So now if I do AZ group list, oh, we forgot to output it as a table. So now I should have a new resource group here with that random number at the end. What I like to do a lot of times when I'm working here in the shell is I'll actually open up the Azure portal on my other monitor, and that way I can hit refresh here and see, hey, that resource group that we just asked for has been created here as well. So I can kind of keep those two things side by side. So there's my resource group. When I'm creating a database server in Azure, the first thing I need to do is actually create the logical server container that's going to hold that server. And that's where my username and password actually get set up or get deployed. So I'm going to go ahead and do that. And again, I'm just doing these all with these procedural CLI commands. And it does take a second to create the server. That is a great question, Nick. So Nick asks, is there a way to analyze an existing Azure resource group that you've created either via CLI or via the portal or however, and export the ARM template based on it? And the answer to that is yes. And after we finish creating some stuff, let's go try that out and see what that looks like. So there's my SQL server. It's created. I'm going to set a firewall rule on my SQL server like we would do normally. And then after I do that, I'm going to go ahead and create the database. Paste. So those are the 3 steps to basically getting a running SQL server out there. It'll take a minute to create this database. While we're doing that, let's go investigate what Nick's question. So if I go back over to my Azure portal and I go find my resource group, in that resource group now we should see some stuff. And here's some stuff. It has my SQL server. My database hasn't deployed yet. But from within here, I can go ahead on the resource group here level and press this export template button, and that will give me a ARM template for the resources that are deployed to that resource group. So it will generate that ARM template for me. So hopefully that answers your question, Nick. And feel free to post any follow-ups here in the chat. So it's still generating the template, but here's my resource. Here's my ARM template. So in that guy, so there's my database. It's fully provisioned. So now I have a running database in Azure, created procedurally. The script and the step that we just ran through are all in that download that you can get a handle on. So here we saw how to create that database using a procedural technique. Let's create that same database or a similar one. Let's create that same database using an ARM template. And I'm going to run the commands, and while it's running, we'll pull up the ARM template. So we're going to do some stuff that was very similar to before. So I'm going to go ahead and hit clear. So we can start over with a blank screen. We'll paste in some stuff. So here I'm just setting some variables again. And these are bash variables. So these are variables inside of my bash instance. So I'm creating a project name. I'm creating a new resource group name. I'm setting the location to be the same thing it was before. I'm creating a new server admin and a new admin password. Now we're going to go ahead and create our resource group just like we did before. No difference. So I'm going to go ahead and paste in that command. So now I have a resource group using those bash parameters. It is a good resource group. It is called my resource group, and there's its number and whatnot. Now I would need to deploy. Now I want to deploy my ARM template. Now in this case, I have deployed this ARM template. I've copied this ARM template out into GitHub. So I can actually say when I deploy this ARM template, create me a new deployment for this resource group using this template. Now here I put my template out on GitHub, which makes it really easy for you all to see the template. It also makes it really easy for me to deploy it because, well, it's sitting out there. I could have uploaded that template to the Cloud Shell and then deployed it locally from a file that's inside the Cloud Shell. While I'm deploying my template, I'm going to override a certain set of parameters inside of my template. And here I'm taking these things, which are a set of key value pairs. On the left-hand side, we see the name of the parameter inside of my ARM template. On the right-hand side, we see the name of the, in this case, it could have been a string literal, but in this case, I'm using a bash variable to pass that value into the ARM template. It just makes things a little bit more readable. So that ARM template is out and running right now. So let's take a look at what that ARM template looks like. So I have VS Code running here, and let me pull up that ARM template. Here it is. And my ARM template is broken up into a number of sections. These sections define what's going on inside of my ARM template. And I'm going to try to make the font a little bigger for you guys because that was a little teeny. Oops, that's a little too big, I think. So here's my ARM template. In my ARM template, I have three major sections. I have my parameters section. This is data that's coming into my ARM template from an outside resource. I have my variable section. These are, well, variables that I'm going to define inside of my ARM template. Maybe I'm going to take those parameters. I'm going to concatenate stuff to them. I'm going to supercharge them somehow. And then finally, I have my resources. These are the actual things that I want to go ahead and deploy. So I look at this parameter section. You can see that I have things like location as a parameter, right? We just passed that in, right? That location parameter is of type string. I have a default value. So if it's not specified, it's going to go and pull the location of the resource group by default. And then I have a little bit of metadata, so somebody reading this ARM template or using this ARM template can actually get some idea of what I meant by that variable name, right? We should comment things. So here I have those four parameters. We saw them. What's of note here is that something like a password, I'm using a secure string data type in order to store that password securely as it's being used inside of this ARM template. So that's the data coming into my ARM template. I then am calculating some data inside of my ARM template. Namely, I want to take the project name that was passed in, lowercase it in the case of my database server name, and then concatenate it with another word. So I'm going to take project name and concatenate the word server on the end to come up with my database server name. Take the project name, concatenate the word DB on the end, and come up with my database name. So this gives me the ability to create new data inside of my ARM template. And finally, the meat of my ARM template is going to be the resources section. The resources section is going to define all the resources, hence the name resources section, that my ARM template is going to deploy. In this case, I want to deploy a SQL server. I want it to have a name that is my database, that is whatever value that's in my database server name variable. I want it to live in the location place, the place that I specified the location. I want the version to be this API version, and I want to set some properties on that database, namely, what is my username and password, right? What database version do I want? So you can see here this JSON document has this mixture of variables and kind of code inside of it, even though it is a declarative document. So in here, I have a resource, and my resource has resources of itself. So this resource, the SQL Server, has child resources of a firewall rule and a database. All of the same things that we created in that bash script moments ago, right? These resources here have a dependencies set. So in here, I'm saying that this resource, i.e. the database, has a dependency of, well, the SQL Server running. And the firewall has a dependency of the SQL Server running. So what this is allowing me to do is allows me to say, hey, I have all these resources, but they actually exist in this dependent hierarchy. I can't create the firewall rule if I don't have the server already. So what Azure is going to do when it sees this ARM template is it's actually going to deploy these things in the right order by looking at that dependency chain. It's going to deploy them in the right order, and moreover, it's going to parallelize the deployment so that if I have two resources that maybe take a long time to deploy, but they don't have dependencies on each other, go ahead, Azure, and deploy those things in parallel. So that is my ARM template. And if we switch back over to the Cloud Shell, we should see that my ARM template has fully deployed. Yay. And if I go look in the Azure portal now, I should have another resource group. Refresh. Another resource group that I just created. I think it was this 26369 guy. And it should have all of the same resources that we expect in it, i.e. our database server and our database itself. The other big difference here as well is that when I deploy using this ARM template, you can see I have here a deployments and one succeeded on my resource group. So as it's deploying or after it's deploying, I can go look at that deployment information and see that, hey, this ARM demo deployment happened at this time, right? And I can see all the information about that deployment, who did it, all the steps that happened and whatnot. So I now have this log of everything that happened inside of that deployment, all kind of nicely packaged up and grouped up for me. Again, awesome for repeatable DevOps kind of environments. So I know what you're saying. Sean, you deployed this thing using a Cloud Shell command, right? You deployed it using a Cloud Shell command. I need to integrate this inside of my DevOps pipeline. How do I do that? So here is an example. I'm not deploying the database here, but here is a good example of deploying it using Azure DevOps. So here's my Azure DevOps. In my Azure DevOps, I have a release pipeline. Now I've chosen to build a release pipeline that just releases my infrastructure bits, i.e. deploys my ARM template. So here you can see that release 2, when it was done on July 17th, was deployed out to my dev, my test, and my production environment successfully. And currently, noted by this darker green, this green background here, currently release 2 is what's released to those environments. So if I go in and edit that template, I can see the release template, not the ARM template. I can see those same 3 stages, dev, test, and prod, and you can see that they just have one little step inside of each one of them, which is basically use the ARM task, the Azure Resource Group deployment task, to go out and deploy to this resource group this ARM template. So I can go pull that ARM template out of source control. In this case, it's actually part of a release artifact, and I can deploy that template right from within the portal as part of, right from within Azure DevOps as part of my release pipeline, with all of that great stuff that Staniff was talking about, like auditing and logging and gated checks and all of that other great stuff. So I know I'm getting close on time. So let me go back to the PowerPoint. So we saw a demo of creating the server using the CLI. We saw that more or less the same server getting created using an ARM template. And then we saw how we can automate that delivery via an Azure release pipeline. I chose the GUI pipeline. You can also deploy these things using the YAML pipelines as well. We talked about a lot of this stuff already. I'm going to kind of fly through it so we have a couple of moments for questions, but feel free to post your questions in the chat as well. And I will derail myself to look at them. So we talked about the ARM template. It has parameters, variables, resources. I don't have any outputs in the example I gave you, but you could also have outputs. It is a declarative way of describing what I want deployed. Some tips and tricks, right? Try to minimize parameters, don't use too much of them. Use metadata to give comments so that people using your ARM template know what it does. Make sure you define default values where it makes sense, and using that secure screen type like we talked about. I didn't have an example of it in mind, but you can also put a list of allowed values as well to make it even easier for somebody consuming your ARM template to know what to go put in that section. To give to that variable. Variable templates, variables are easier to read and edit. It allows me to build up those strings in one place and make the rest of my template easier to read. Allows me to build out complex objects. We saw that nesting where a resource, i.e. in our example, the SQL Server had other resources nested inside of it. And I'm allowed to set up custom values. We saw that with the variables. So here is some more examples. Again, you have all these PowerPoint. You have all this PowerPoint. Use comments. Don't stick your API version in a variable. Use things like secure string to deploy your secrets. Here's some more examples. Again, we saw that a resource can have a dependency on other resources. We saw deploying it via the Azure CLI. I can also obviously deploy it via PowerShell or via REST. So again, some tips. Again, we're kind of running short on time, so I'm gonna kind of just build out the slide. I went too far. So again, all of these things are in the thing. Don't copy paste code. ARM templates have this thing about have this mechanism for doing looping. So if you need to create 100 databases, right, you can create a loop and create the databases one at a time. Avoid using things like run once behaviors, right? The goal is that your ARM templates are idempotent, so that you can run them over and over and over again, and all the run once if declarative stuff kind of breaks that concept. There are a number of advanced ARM functions that are available, things like concatenating. We saw that, right? I want to stick two strings together. I can write conditionals inside of my ARM templates. I can do string functions like to lower to get things little letters. A lot of things like a storage account can only take little letters. We have this idea of a resource ID. Inside of Azure, every resource, every service you deploy has this identifier, this URI that identifies uniquely where that resource is. It is the subscription / the resource group name / the type of resource it is / the resource name. And you can get at that resource ID. You can see that resource ID all over the place in Azure. You can also build up that resource ID inside of an ARM template using this resource ID function. I can link and nest templates in order to build out more complicated deployments, so things don't get so one template doesn't end up with 10 billion lines of ARM in it. Here's an example of that. A bunch of resources. Again, you have this PowerPoint deck, great Azure Docs where you can find out all of the commands for working with this ARM template stuff. There's an Azure learning plan with step-by-step instruction, step-by-step hands-on lab kind of stuff for doing most of this. There are plugins, extensions for VS Code in order to do ARM, to write out your ARM templates and make that stuff easier. There's resources.azure.com, which I didn't leave myself enough time to talk about, which is another great way of seeing the ARM for deploy resource. As Nick asked, you can pull ARM templates from the portal. There's also a library of templates that you can get access to. And then there's a question in the chat. Can you please confirm if the entire Azure is Linux based? I guess it depends on what you mean by the entire Azure. There are many Azure services that are Linux based. I can deploy Linux VMs. I can have Hadoop clusters that are Linux based. But there are also many Azure services that are Windows based. Last stats I saw, it was like I think Linux was a little bit higher of a percentage of VM instances in Azure. I can talk to Azure from Windows or Linux base, but I don't know if I necessarily understand what you mean by, Larry, by the entire Azure. Again, here's my contact information and the bit.ly where you can download the slides and stuff. And I am right on time, so you guys can go to your next section. Thank you very much.
Thank you, everybody. We'll see you in the next session. Thank you, Sean, for a great presentation.
No problem. Sorry I went a smidge long.
No, you're perfect. Thanks.